Hello everybody. Today I'm going to test and review this battery pack from Alarm Hookup on eBay. This is the Sona 18650 cell battery pack, 36 volt battery pack, 4 amp hours. It's promised that it comes out of it, and it has 20 cells in it. It's 10S2P. The cells that are in this battery pack are from a company called Lishan Battery Company in China, and it seems to be a reputable company from what I can see. I found some of the specifications for it, so I'll bring those up here. You can see here the eBay listing. We'll come back to this in a second. Let's go down to my there we go. So there you go, Lishan Battery Company, China. Specifications, this is the cells in this thing are the LR 18650 L8 cells, and they're rated at 2000 milliamp hours each, and you can see the rest of the actual specifications there that I found. They do say that these are 20 amp cells. That would be continuous. I'm not sure what they are in full or burst power, or how much they could take, but we'll talk about that here in a second. And like I said, you can see all the specifications here, but I'm going to go through it top to bottom and see what we get out of it. Let's minimize this. And basically, in the description for this battery pack, you'll see that they say that the seller says that it goes up to 40 amps max per cell. I couldn't verify that anywhere, so that's just you can do your own research to see what you can find. Also, it does have a BMS on it. The seller does not say that the BMS is a balancing BMS, so I'll be testing it anyway for balancing overcharged, discharge, capabilities, and cell protection capabilities. In other words, top to bottom, like I usually do for this battery pack. So let's get, well, here's what I found about the company. There's a profile on the net about Lishan. As you can see here, it's a private, state-run Chinese company. So, again, seems to be reputable. I can't really verify, but seems reputable. And then some more listings here. Here's one selling this cell. I believe it's from China as well. And, be glad if you get it in this pack, because these guys want $5.95 for each one of these cells. So you're getting it for a lot less than that. I will put the price breakdown in the video description below for everybody, so you can just go down there and see what the eBay listing price breakdown is. It's listed by Alarm Hookup under different packs. I think this is a single. You can get 5, you can get 10, 20, 50, and so on. These packs. So obviously he's got lots of these. So if you want to do a bulk order with him, you can contact him or go through one of those eBay listings and just purchase it that way. Again, in the video description below. So let's get on to the physical setup on this, or basically the physical size and weight. And then we'll peel it back and see what's underneath all this wrapping, which seems quite easy to take apart. Okay, here's what we have physically. Typical package for these packs. It's got this sort of cardstock tape all the way around it, and then on the back it has a little bit of mylar. That's different than the others. The other ones I saw or I have are all cardstock tape, so I'm not sure what that is. It's a little cracked there, but no big deal. This is what we have, and your typical XT60 connector on the end. Let's see, a regular size lead on it, I would say. And if you need a longer one of these, you could just basically disconnect this, put a solder on a longer set of wires onto that same connector, and you'd have a longer lead. So that's it for what it looks like physically. That's basically how the Sona looks right out of the box. I'll open it up and show you the BMS, which is side mounted right here, in a minute. But right now, let's just do let's weigh it up, see how much it is. And I'll do both metric and imperial here. Start with grams. 935 grams. Ounces, 32.98 ounces. So that's the weight. Let's go over the physical dimensions here. Again, we'll do metric and imperial on this. Okay, length 134.37 millimeters, or in inches. 5.29 inches, or 5 and 37 1/28 inches. So that's the length. Let's do the width. 84.99 millimeters, or 3.346 inches, or 3 and 11/32. And let's do the thickness. 57.93 millimeters, or 2.2805 inches, or 2 and 9/32 inches. Okay, that's it for the physical. I'm going to peel it back a little bit here so you can see the BMS. Let's start there. Now, this is adhesive tape here. I've taken this off already once, just for my own curiosity, and so I can show you what's going on. So this comes off easy the first time, but I'm sorry, the second time. First time was really tough. There's a label here with some model number for this, so I'll zoom into that in a second, but right now I just want to show you the BMS here. And the nice thing about this BMS is, I don't know if you can tell or not, but yeah, okay, let me zoom in a bit. All right, a few things about this BMS. Number one, it's got 11 lead connector, which is different from the LG battery pack that I have with the side-mounted BMS. It only had a 10 lead connector, but you can see here the black lead, and that's the negative lead going to the negative terminal on the battery. And I'll show you the circuit diagram on this, well, the circuit diagram for the battery pack on this, not for the actual BMS itself. And you know, so you can see how this is all hooked up. So that's cool. You see that the circuit board is on the bottom, and you have this metal cap on the top. Now this metal cap here is actually a heat sink for the components on the inside. So that's a nice thing to have a heat sink on that BMS. This is the first one I've seen with this on it. So this big plate, metal plate here, acts as a heat sink for the components on the BMS, which should make the BMS a little bit more robust. As the cooler you keep electronics, the better they work. So, you know, and I probably will, at the end of this video, just take the top off of this so you can see what it looks like underneath. So let's go take a look at that model number for everybody. The model number is DLX-901-3L10S-13N13-W02. You know, and there's some other stuff down here in Chinese. Of course, I can't read that. And also, you can see here it says Vict Power. So, well, maybe you can't. Let's see. Someplace where you don't get a reflection. There. There we go. That's better. Vict Power. So that's who made that. I see a small circuit diagram here. You got the power P negative, the B negative, and that's neat because this actually has the same kind of circuit as the LG side-mounted BMS, which gave us a power takeoff point on the actual BMS so that it could be charged and discharged simultaneously. So while it's actually, if you connect to that point there, you know, I haven't tested this yet, but it, you know, more than likely this is what it will do, because this is what the LG BMS did. It will allow you to charge the battery pack at the same time that you're running a load on it, and you know, pretty cool. But I will test that. But this feature is there on the center mounted BMS on the Samsung battery pack that I got. That feature wasn't there, but again, it's just a nice to have. It's not a necessary. You can actually just, if you wanted to charge and discharge at the same time, really, you could just put another pigtail onto these two terminals here and connect it to your load at the same time that you're charging. It would have worked anyway. So back to this. We've got the connector. There you go. You can see it. You can see that it's been glued on the wires. That's nice, you know. That protects the wires from being pulled out from the connector itself. The connector itself is not glued to the BMS, which is cool. And really, it doesn't have to be because it's on there really, really stiff. That's not coming out. I couldn't pull this off with my hands alone. That's how stiff it's in there. So, you know, I will show you how I disconnected it. I just used a screwdriver on this edge and a screwdriver on that edge and wiggled it out. But that's it physically. You can see the batteries here on the bottom, and they are exactly the LS-LR1856LA cells from, there we go, here you can see that one of them there. Let me flip it around. You can see one of them there, and it's listed correctly, and it looks correct, from what I could see on the internet. And basically, all of them are the same, and they look pretty good. I don't see anything crazy about them. They, standard thing. So let me zoom out. Okay, so there it is physically. I could, strip it back further, but if you look at the seller description on eBay, he takes all the shrouding off, and you can see exactly what it looks like without any of this stuff wrapped up around it there. And I will put links to that in the video description below so you can have a look. But that's it physically. Next, we're going to do, I'll do the circuit diagram of the battery pack so you can see how that all works. Then we will start all the testing. All right, I'm going to show you here quickly how I take this BMS connector off. And question being, why would you want to take it off? Well, the nice thing about this side-mounted BMS, and actually all the BMSs that I've gotten on these battery packs so far, is that they give you a place to actually manually balance charge every single cell in the pack, so that you can have them all at the exact same voltage. So all I do here is just basically leverage the corners like this with a standard screwdriver, a flathead, and just wiggle it out like so. And this avoids any stress on these wires. Like, don't pull on the wires. Not a good idea to pull on those wires. You can see they glued the wires to the connector to keep you from, to protect them from being yanked out of the actual connector, but don't pull on the wires ever. So let's pull that off. Basically wiggle it off, and then now at this point just disconnect it, and there you go. There's an 11-pin connector. And on the circuit side, you can see the actual male end of that right there. There you go. And also you can see how beefy that metal plate is. It's a pretty good thickness there, right? So that's definitely heatsink material, and that will also protect the actual circuit board from impact. So that's a cool feature. Nice plus on this Sona battery pack that wasn't on the other two that I've tested so far. Here we have the circuit diagram for this BMS. Let me go back. This is the second one. This is the primary one. It shows you how it comes out of the box. Basically, you've got an XT60 here at the end, positive negative lead, going to the battery on the S10 battery pack, and the negative is going to the C on the BMS. This is the C pad on the BMS. It's a negative pad. And then from the B negative pad, we go to the battery. And then we have the BMS leads that control the individual cells, basically monitoring the individual cells. I don't believe this is a balancing battery pack. I will test for it, but I doubt it is. And then we have this P negative pad here, which I'm going to call the power takeoff pad. But basically, this is how it's all arranged. I will show you how I'm individually connected to each one of these cells on the connector when I show you the discharge results. So let's go to the other panel here, or the other picture. And here we have the P pad connected to a load, which in this case is a motor. And you can see that the negative lead goes from the motor to this P pad, and then to the positive lead off the charger, or a load, obviously. And in theory, you could have two loads on this thing at one time, I believe. But basically, what this allows you to do is charge the battery pack while you're using a load on it. So pretty neat function. I haven't tested it yet to see if that's how it actually operates, but that's how the LG operated. So I'm assuming that it will go the same way. So next, I'm going to show you how the discharge results from the individual battery packs, so that you can actually understand what you may be getting here on the individual cells. Here's my discharge results. This was taken down from 42 volts down to 27.5 volts. So as you can see here, we got 4.12 amp hours, or 151.23 watt hours. Total time of discharge was 5 hours 20 minutes. You know, that's probably not accurate, as I cycled it a few times. In other words, I you know, stopped the process and the counter kept going. So basically the full discharge is, again, 4.12 amp hours, or 151.23 watt hours. And you can see that you know, it's fairly accurate. My discharge meter is at 30.57, and my meter says it's 30.53, so it's pretty close. A good result. You know, within what is advertised. Actually, it's 120 amp hours over the 4 amp hours that are promised, so pretty good deal there. Next, I'm going to test the over discharge protection by going below 27.5 volts, and seeing what the cutoff voltage is on the bottom end, and then I'll overcharge it and see what the cutoff is on the overcharge protection end. You can see it cycling between 28 and 0.79 and 22.56 here. It's a slow-mo capture of that first clip, and really interesting result, because really the theoretical discharge point where it starts to hurt the cells would be 27.5 with these cells. So it's 1.3 volts higher than the maximum discharge point. So this BMS protects these cells, you know, very well. And my discharge test, actually, I thought I took it down to 27.5, but obviously I didn't, because the BMS would not have let me. They would have let me down to 28.79. So the total discharge result that I got on this video is down to 28.79 volts. Really interesting result. So basically the BMS protects these cells totally. It will never allow them to over discharge to a point where they're going to get hurt. The overcharge protection I got on this was 41.90 volts, or 41.8, depending on which meter you're looking at. Pretty close anyways. I could not get it to go any higher than that. So basically this BMS will never let the batteries to go into an overcharge condition that will hurt them, because it would be above 42 volts, and we're never going to get to that. And here, I'll turn on my charger here, and you can see that it will, and I'll set it to go over 42 volts. There we go. And you can see the voltage goes up to 42.09 volts, but 0 amps, because basically the BMS is stopping the voltage from getting to the actual charger, to the actual battery. I have the battery connected here, and if I disconnect the battery, you'll see the difference right away. 0 difference whether I connected the battery or not. So if I connect it back in again, stop the charger, you can see that it quickly drops to 41.9 or 41.8, depending on which meter you're looking at over here. And let me disconnect the battery now so you can see what happens. And then you go see everything goes down to 0. So the battery voltage is 41.9 or 0.8, depending. And I can't charge it any higher than that. I've tried different voltages, different ways to getting it up, and I can't. Now I did get it up to 42 volts by individually disconnecting the BMS connector here, the battery connector here, and individually charging each one of the cells to 4.2 volts, which brought the whole pack up to 42 volts, and that's how I did the discharge capacity test. But knowing that I can't charge it beyond 41.9 and that I can't discharge it to 27.5, that should change the entire capacity rating of the battery pack as far as what you're going to get out of it using the BMS connected. So I'm going to do a full discharge again, this time, using the limits the BMS imposes on the battery pack. But if you're a battery harvester, it doesn't matter. The preliminary test, the first test, that one actually applies to you because it gives you the true capacity of the cells themselves, not what is being limited by the BMS. So let's do the discharge test next. All right, here we have our results from the full charge to the cutoff point. So charge to the full charge that the BMS would allow to charge, and down to the full discharge point that the BMS would allow to discharge the battery pack before it cut it off. And we got 4.123 amp hours, or 151.31 watt hours. So basically a little bit more than I got when I first charged all the cells up to 42 volts and then discharged it to the cutoff point, or the discharge cutoff point. And impressive results. It looks like the battery pack is actually getting better as I cycle it, so that's a good thing. And it's giving us more output than the actual seller says it will give you, which was 4.0 amp hours or 4 amp hours. So yeah, looks like a good set of cells. It looks like a good battery pack at this point to me. Next, I'm going to just test that the third pad on the actual BMS and see if we can charge and discharge the battery pack at the same time. All right, I've connected XT60 pigtail here, like this one, onto the P pad on this BMS, and the other lead is going to the positive terminal, the same place that this terminal solders onto the battery pack. And I was going to test it and see, how that P negative pad actually worked. And what I realized, I thought to myself, hey, wait a second, is there any isolation between this contact point, this contact point, and this contact point? I mean, this is B negative, like I said, they're all negative connections. And so I got my trusty old continuity tester, and I said, okay, let's test this, right? So let's go to here and here, and we get continuity. Let's go to here and here. We get continuity. Here and here, continuity. So I don't really have to test this pigtail connection that I soldered on here, because basically this P negative is just soldered. It's a solder point to the ground on the BMS, just like this is soldered to ground on the BMS, and this is soldered to ground on BMS. So in reality, you could just take a pigtail like this, and even if you don't have a P negative power takeoff pad on your BMS, all you need to do is solder onto the positive terminal of the charge cable here, that positive, and any one of the negative points on the negative BMS, and you'd have the same result as soldering this pigtail onto the P pad. So I'm not even going to test the P pad. There's really no need, because all I'd be testing is the exact same function and circuit that you test when you test this. So basically it's just a convenient soldering point on the negative rail of the BMS here. There's no need to do that. So lesson learned, number one. Number two lesson learned is that, any one of these battery packs that you want to charge and discharge at the same time, all you got to really do is connect another pigtail like this to the exact same points that this one is soldered to, and then you'd have one on the charger and then the other one on the load, like this one, and you could charge and discharge at the same time. So that P pad really is there just as a convenience, but there's no additional protection being provided by that wouldn't be provided to the this lead here. So that's what I learned. I'm not going to test it. There's no point. It'd be like basically it's just testing this lead again. All right, to summarize, the Sona 36V 18650 battery pack. It is a 10S2P battery pack, meaning that you get 20 18650 cells for $34.99, and all of them are over 2,000 milliamp hours. 2,000 are, well, not over, are either 2,000 milliamp hours or higher in capacity, so it's certainly performing exactly as Alarm Hookup would have advertises on his eBay listing. Put a link for that in the video description below for you guys so you can get that easily. Yeah, at $34.95, pretty good deal just for the cells alone, but it does have a BMS on it. BMS is really solid from what I can see. It actually protects the cells really well from overcharging and over discharging, plus has a nice heatsink plate on the top of it, which I did not see on the LG or the Samsung battery packs from Alarm Hookup. So that's a plus, keeping the circuits cool, number one. Number two, that metal plate will also protect the BMS from external strikes. So if you were to hit that BMS from outside, the components would be actually protected. So, you know, that's another plus. If you're going to use this battery pack externally, by itself, I would definitely heat shrink it. Put some heat shrink tubing around it just to give it that extra, protection layer around the outside. I mean, this paper tape is okay, but it's not the greatest, and I think heat shrink tubing would make it much more robust as a battery pack by itself. So that's, up to you how you do that, how to use that. Yeah, other than that, it's a solid performer. I didn't have any issues with it. Worked great, and I have no problem recommending this battery pack at $34.99. Now, I did look through the Alarm Hookup's listing on eBay, again in the video description below, and I noticed that the LG battery pack now is at $34.99. So this one's considerably cheaper. Sorry, at $44.99. This one's $34.99. So this one's $10 cheaper than the LG battery pack. I couldn't find the Samsung battery packs. That probably means that he sold out of them, but I may be wrong. Maybe they're available there. And he does have bulk discounting on these packs if you message him, or maybe he has a listing where he's selling 10 or 20 of these at a time, and they become cheaper at that point as well. So great battery pack. This is a Sona battery pack from Alarm Hookup. Again, video description below, you find the link for it on eBay. And yeah, no problem with that battery pack or recommending it. Okay, that's it for my video. If you like this video and it helped you out in some way, do me a big favor. Click on the like button here in the bottom right hand corner and give me a thumbs up. Okay. Now, someplace on the screen here, usually around here somewhere, you'll see a picture of me. That's a subscription link. All you got to do is click that and you'll be subscribed to my channel. And anytime I put a new video up, you'll get a notification that I put a new video up, but only if you click on the alarm icon that now comes up when you go to subscribe. So when you hit subscribe, you'll see an alarm icon. Click on the alarm icon, then you'll be notified every time I put a new video up. Okay, like always, I want to thank you for your time and for watching.